Hello everyone, welcome to the third lecture of this course. And today we are going to learn about how we can repeat some set of commands using loops. So Julia language is offering us two loops. One is a for loop and another is a while loop. So in today's lecture, we will learn how to use these two different kind of loops and what are their use cases. So that will be our main focus for this lecture. So let us begin. The for loop and while loop, the common thing between them is they both iterate over a repetitive task. Okay. So say if you want to print all the elements of a 1D array, which is vector, you have learned this in the previous class. So let us define a 1D array. So the elements are 1, 2, 3, 4, 5. And suppose we want to iterate over all these elements and print them. So one way to do it will be using the println command and manually addressing each element. And again, I have to wrap it within begin and end. Yeah, you can see that everything is being printed. Now, the one flaw of using this workflow is that we are writing the same code again and again. So this is not at all recommended when you are doing programming, because when you are writing more code, the probability of you making errors will be more. So it is best to avoid writing the same code more than once whenever possible. And another thing is that we don't know, when we're writing like this manually, we don't know how many array elements are there, or if they are changing, it will not work. So for example, this is now working, but let me increase the element, increase one element of 8, add an element 6, and you will see that still it is printing up to 5, because that's what I have manually mentioned. So here it will not give an error, the code will still run, though it will be incorrect. But if we delete the last two elements, now it has only 4 elements, then if we save it, you will see that we'll get an error message that attempt to access 4 element vector at index 5. So that is telling us that the vector A has 4 only 4 elements, but we are trying to get the element 5. So that is again an error in our code. So what is the optimal way of doing it? So let me comment it out. The optimal way of doing this will be to use a loop. So we'll be starting with for loop first, and let me quickly discuss the syntax of how to use for loop. So we use the keyword for, and we use a dummy variable, say I. So you can put any name here. Then we use the keyword in, and we specify an iterator. And then we do something with the dummy variable I. And then again, as we have learned for using if-else statements, we have to, whenever we are using this for loop, we also have to end it. So this is a must. Okay. So this is just indication to the programming language that I am closing the work of for loop here. So this is not an indication that the for where the for loop will end. So again, the job of a loop is to do a task or execute a command, whatever you want to call it, repetitively. This end statement is not defining when the loop should stop doing the repetitive task. Okay, so I hope the syntax is clear. I will give you a couple of examples so that you can see it in practice. So suppose we go again trying to print our elements in this array A. So let us do this using the for loop. So how are you going to write it? Let's look at the syntax. So it is first the for keyword, then we are using a dummy variable, call it A, then the keyword in, and then we have to specify an iterator. And iterator is a data type over which we can iterate. So this is the data type over which we can run the loop, which has multiple elements. It can be a tuple, it can be an array, it can be matrix, vector. So those kind of things which have multiple elements, and we can pick and go to each of them one by one. Okay. So here we already have a vector defined, and okay, this will give us an error because we have not completed writing it. So here A is our iterator. Okay, so we will write for I in A. And what do you want to do? Do something. So let us just print I and A. And again we have to end. So let us run it. So you can see it is printing. So here this print command is being run iteratively. And how many times it will run? Until we are out of elements to iterate over. Okay, so that means if our vector has 5 elements, it will run 5 times. If it has one element, then it will run only one time. We can check if we increase our element in our array here, we can see that it has run 5 times. We can hide this cell so that we can see it clearly. Let us append another element, and we will see that it is now running 1, 2, 3, 4, 5, 6 times. Okay, so when running this loop over an iterator, it will run length of A times. So how long the loop will go? So length of A is 6, so it will run 6 times. And what is this value I here? You can see that this is the first thing that is being printed before we are printing the vector, and I is repetitively storing the value that we are currently iterating over, which is stored in A. So if A is 1, 2, 3, 4, 5, 7, then for the first iteration of the loop, this I will take the value 1. Then on the second iteration, it will take the value 2. On the third iteration, it will take the value 3. On fourth, it will take the value 4. On fifth, it will take the value 5. And on sixth iteration, since the element here is 7, it will take the value 7. So here I is actually going over all the values that are stored in this vector one by one. So when we are writing for I in A, that is, we are telling the program that we want to go over all the values that are stored in the vector A one by one. So it will access the value which is at index 1 first, then it will access the value in the next iteration of the loop. It will access the value which is stored at index 2, then it will access the value which is stored at index 3, and it will go on until there are no values to access. So let us again check it. Let us append another element 99, and if we save it, we can see that on the seventh iteration it is printing the value 99. To check it properly, we can also just print the value of I, and you can see that it is printing the values 1, 2, 3, 4, 5, 7, 9 as they are stored in this array A. So that is a very basic use case of doing repetitive stuff using a for loop. So we can do the same thing using a while loop also. But before going and learning about while loop, we must learn about what different kind of iterators Julia offers us. Okay, so we have already seen that arrays, vectors, which are 1D arrays, matrix, these are iterators. So do you have any other type of iterators? We actually have, and we'll be learning about unit range first. So this is a data type which is parameterized by a start and a stop of type T, and it is filled with elements spaced by 1 from start to stop. Okay, and the syntax is A colon B. We'll learn about that syntax later, but first we'll use this like this. So you can call it like this. This is the type, and then we can specify a point where it will start, and then you can specify a point where it will stop. If we run, you will see that giving us 1 colon 10. So let us store it in a variable called A. And this is again one kind of iterator. So if we run a for loop over it, you will see that it has printed all the elements from 1 to 10. So this unit range is a way to generate 1 to 10. How can we just check the type of unit range? If you type it correctly, you will see that this is a unit range. The data type is a unit range which is storing in 64 elements. Now suppose we want to store floors, so we can do it in two ways. We can define one of the start or stop values as a float number, and then we can check the type of B, and it will be a unit range of float 32, or we can just use a decimal point number like this. Um, Sorry, there was one parenthesis extra. You can use a decimal point number like this, and it will default to float 64. So like this, you can also use different data types with unit range. And if we print it, you will see this has to be B. You will see that it is printing everything in float. So even if one of them is int, another is float, you remember that we learned about the promote function earlier in the previous class. So Julia under the hood will use the promote function to in such a way that all the elements are of same data type. Okay, so that's how we can use the unit range data type. So similarly, we have two other data types. One is called step range, and another is called the lim range. And all of these unit range, step range, lim range can be accessed by the range function. Okay, and some simple stuff like unit range or step range, they can be used via the colon syntax also. So we'll learn about all of them very quickly. So we have learned about unit range. Let us go and learn about step range. So how do you define step range? Let us define assign a variable c, and we similar to unit range, you can do it like this. And if we see the live talk, we'll see that it ranges with element types of T with spacing of type S. Okay. Now the step between each element is constant. That means if we want here the step between each element is 1. If we want anything other than 1, we should use this step range function. So it is written like this: 1 to 10. So what is it is doing? You will see that it is mentioning 1 to 9, not 10, and we will quickly see why. Here you can see that it is generating elements at intervals of 2. So this is our start position. Then we have our interval, and then we have the end. So it is not necessary that it will also contain the end or stop value, because you can see when you are generating these numbers with interval of 2, we will get 1, 3, 5, 7, 9, and then the other number will be 11, which is over the stop value. So this step range method, this will just generate the values so that it is less than or equal to the stop parameter. Okay, so that's how we can generate a step range. And since the last element here is 9, the Julia Reckel will also assign them like this instead of 1 colon 2 colon 10. So we can also do it like this, and you will see that still it will say this 1 colon 2 colon 10. No, sorry, 9. It will not say 10 because 10 is not the element, the last element here. Okay, so that's how we can use step range where we want to generate this collection where intervals is not equal to 1. Now we'll see another kind, which is lean range. What does it do? If we quickly write it and assign it to a variable d, and this will be println. Okay, again the syntax here is start, stop, and then how many points. Okay, so with step range we are specifying what the interval will be, and with lean range we will be specifying how many points do we want to have, and here the start and stop point will be inclusive. Okay, so here you will see that it doesn't matter how I change this how many points parameter, it will always include. Of course, if we make it 1, this will not work. If we at least make it 2 and more, you will see that it will always include the start and the end point. So if you want to generate numbers in such a way that your start and stop point are fixed, and it should always be included in the vector or the matrix that you are generating, then lean range is a wonderful method where you can just give the parameter how many point you want to generate, and it will calculate the interval accordingly. So you can also make it 4, 7, and you will see that it will always gonna work. Okay, so here it is 8, but some it is showing as 7.9999, which is 8. Okay, so you can see that I have tried it with different parameters for different values for this how many point parameters, and this is actually called the length, and again this length, it has to be integer. Okay, so now we have learned about unit range, step range, and lean range. Now I discussed earlier that they can also be used with the range function, and they can be used via the colon syntax also. So we'll quickly see how one can do that. So if you want to use unit range, you can use this syntax, just start and stop. So let me assign a variable, say f1, say 1 colon 10, and let us put everything in begin and end block so that we don't run into an error. Then let us print the type of f1. You see that you are getting a unit range, but the points are in 64. So if one wants, we can just make it in 32, and if you type it correctly, we'll see. Okay, so here 1 is also in 64, so you have to make both of them, otherwise it will get promoted to the higher order number. So you can see now it is in 32. Another way of doing this will be like this. So this is a very unique syntax. We have discussed part of it, but let's skip this for now. I will discuss this after some time. Okay, so here we are getting a unit range of int 64. Then if you want to get a step range, what we can do, we just have to give the step. So let me call it f2, and you will see that once you are using this 2 colon syntax, so the first colon will be signifying the start, then the second number will be interval, and then after another colon will be providing the stop value, and this will give you a step range. Here the first in 64 is the data type of start and stop, and the second in 64 is the data type of interval. So here you can put int 32 also, and you'll see the second data type will change. Now you cannot generate a ling range. Colon syntax is reserved for int range and step range also, but you can use the range function. So let me quickly show you how we can do it. So if we just type range 1 to 10, you will get this 1 is to 1 colon 10. That means it is a unit range. So again, we can check. Let us make the variables g now. And again, I have mistyped it. Yeah, you will see that the type of G1 is a unit range. What will happen? If we put another number here, so you can see we have used this one here, range start stop. You can also specify the length and step. So if you want to specify the state, we can do it like this. Similarly, we can also specify it like this. Okay, these are the same variables. And just to be sure, we can also print them. Again, one end is for this begin block, another is for the for loop. You can see that here we are getting 2 points. So this will be a iterator which only have 2 elements. Because we have specified the length to be 2, we can make it 5, and then we will have exactly 1, 2, 3, 4, 5 elements. And since this was disabled, we can copy this part and paste it, and write the interval like this. So you can see the values are 1, 3, 5, 7, 9. Similar thing one can do here also. And here you can see, since this is a unit range, all the values of 1, 2, 3, 4 up to 10 is generated. Now, it is not very useful to use a for loop to see all the elements, right? All the time when you are just defining these step ranges or ranges, you will be seeing this 1 is to 2 is to 9, this kind of syntax. But if you want to print the elements one by one, then you have to use a for loop. So there is another way where you can see all the methods, all the numbers. So that is to use the collect function. So the collect function will return an array with the given element type of all the items in a collection or a iterable. So these are iterables. So here, if you want to collect all the elements of that iterable or the collection, we can just write start with G1, and what it will do, it will here if you type get the type of G1 and type of collect G1, you'll see that G1 is unit range, and what this collect function is doing is it is converting into an array. Since this is a 1D array, it will be called a vector. So you can also use this collect function, which will be just converting it to an 1D array, and since all elements of arrays and matrices are shown in the REPL, you can see all the elements whether they are generated correctly or not. Similarly, we can do this for G2 and G3 also. Okay, so far in today's lecture, we have learned about why we want to use loops in the programming language and what is the use case of those. We have learned the syntax of for loop, and we have learned about different kind of iterators like unit range, step range, len range. So these iterables gives us some predefined way of generating values depending on what the use cases that you have. Okay. So, and we have also learned about this collect function, which will convert any collectible or iterable to an array. Okay. So let us go to the next section where we will be learning about while loop. Okay. So let us learn about while loops. So before starting while loops, I like to address something. So in the previous sections, I might have said that this range, these are iterators. That is actually incorrect. What I wanted to mean was that these are iterables. Iterables are something which we iterate over, and iterators are something which help us iterate over iterables. Okay, so that means the while loops, for loops, those are our iterators, and the arrays and these unit ranges, state ranges, bin ranges, those are our iterables or collections. So this collect function will work on collections or iterables, and these loops are our iterators. So as in some cases, I might have said that these ranges are iterators. So that is an incorrect statement. I want to correct myself here, and you guys also note that this is the correct nomenclature. Okay. So with that, let us begin learning about while loops. So the syntax of while loop in Julia, let me go over that. Okay. So we use the keyword while and then some condition. Okay. So the loop will run as long as the condition is true. So it is our job to make sure that this condition becomes true while the loop is doing the repetitive jobs. Okay. So we have to make sure to change the, not the code, change the variables or numbers in such a way that the condition which is given here becomes false after some iterations. Otherwise, we are gonna run into the problem of a infinite loop. So an infinite loop is a loop which keeps on running without stopping. So with while we can do infinite loop, but it is always a good programming practice to make sure that the while loop that you are running ends, and this condition has to return false after some time. Okay. So, and as we have seen with for loops also, we have to make an end statement. And again, I want to stress that this is a syntax. So this end does not signify where the loop will end doing its iterations. Okay, this is just to let the programming language know that I have stopped writing the code which the while loop will iterate over. Okay, so again, just let me go over it once more. The while loop will run as long as the condition is true, and we can do the task that has been defined inside this while and end keywords repetitively as long as this condition is true. And we have to make sure that we do some changes. We make our code inside this while and end block in such a way that it changes the variables or numbers in such a way that these conditions sometimes become false. So if it does not become false and it always remains true, then the while loop will keep on running. So we'll not see an example of infinite loop because that might crash the notebook here, but we will see how we can use the while loop to do some iterative stuff. So let us take a simple problem, say print all integer numbers until 10. Okay, so let us start with 1 and let us define the while loop. What will be the syntax? We have to use the keyword while. Then we have to give the condition. What will be the condition here? We have to print all integers until 10. So we have to check when the start variable is less than or equal to 10. Okay, then we have to print start and end. Okay, so here you can see if when it runs, we'll see a lot of 1, 1, 1, and 1. And since I have not changed the variable start here, this while loop has run into a infinite loop, and it kept on printing ones. You can see how many ones it has printed, and it kept on running this println statement until I manually blocked this execution of this cell. So to make sure that we don't run into it, we have to increase the start variable by 1. So on the first iteration, our start is 1. This condition start less than equal to 10 will be true, and then it will print the value of start, which will be 1. On the second condition, and the second line, the value of the start will be start plus 1. That means it will increase by 1. Then while doing the second iteration, it will be checking this statement, which will be 2 less than equal to 10, and that will again be true, and it will again print 2. The start variable will become 3. Then it will check whether 3 is less than equal to 10, and then it will again print. And when the start variable becomes 10, then it will print 10, and then after increasing by 1, this variable will become 11, and then this condition 11 less than or equal to 10 will be false, and that's when the loop will end. So let us run this now, and you can see that it has printed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is the start. This is the repetitive task where start variable changes, and when it becomes more than 10, the condition of the while loop will be false, and the execution of the loop will end. So this is the, just to avoid confusion, let us say this is the beginning where start less than equal to 10 is the condition that will be checked every time the loop is starting to do its iterative job. So suppose one makes this minus 10. What will happen? You can run it and you'll see that it will not run because the starting value 1 is less than minus 10. This value, this statement then will be false. So this loop will not run a single time. Okay, so this part of the code is non-existent now because this condition will be false since the first case. Also, you can do that in for loop also, but in while loop, there might be possibilities where the code will not run a single time. Okay, now suppose let us change it. Let us copy it and paste it. Now, suppose we want to do it like this. Okay, and we have, let me remove this annotation. Yeah, so what we are doing here, our start variable is 1, and we are checking whether start is less than 10. And instead of increasing it, we are decreasing it and in every iteration. Now, if we run it, we are again running into the problem of an infinite loop. So if we stop the execution using this button here, and you'll see the output here that is started from 1, then it becomes 0, -1, -2, -3, -4, and it went on up to this number until I stopped it. So this might also happen. I will just comment it out. This might also happen that you have mistyped something, although the problem was not intended like that. You have mistyped something and your loop will enter a infinite loop. Then also you might need to stop the execution of the loop manually. So this will become an infinite loop. Okay. We can also stop these while and for loops using a keyword called break. So we'll quickly see a use case of this also. So let me copy this. So here this will become an infinite loop now. But since we do not want it to become an infinite loop, we can give it a check that if it is negative, then we will break the loop. So this break statement, whenever this will execute, it will stop the currently running loop. Okay, so if there are nested loops, for example, in the last class, we have learned about nested if-else statements. We can similarly write nested loops also. So if there is a break statement which occurs within a nested loop, then it will only stop the nested loop and the parent loop will be still executing. Okay, so let us run this. So here you see that our start value was 1, and since 1 is less than equal to 10, it printed it. Then our start value become 0, and it was checking if start is less than 0. That was 0 is less than 0, and that was false. So it didn't execute this break statement. Then it went on and iterated the loop once more. So then it was checking whether start, which is 0, is less than equal to 10. That was true. That's why it printed 0. Now the start value become -1, and this statement become true. So this code block, which is under the if block, will get executed, and when the break statement gets executed, the loop automatically ended. Although this earlier case where we didn't have this break statement, it was going on forever and it became an infinite loop. Here, by manually typing the break statement, in such a way that it will execute at some point. We can break an infinite loop also. So that is one example. And let me give you another example where we will see nested loops and break statement. So let us do it like this. So let me define one variable, say var, and start it from 0. Then we will check when var is divisible by 5. Then it will do something. Then it will print var, and it will do var equal to var plus 1. So if we run it, and var not defined. Okay, I haven't run this also. So you see now the way it is defined, it is just the first case when the value is 0, the remainder will be 0, and that's the only case where this is running. So then it will become 1, and this statement will become false, and the loop will automatically end. So suppose we want to make this command simple. So say when var is less than equal to 10, then we will define another variable, say 1. So what we want to do, we will print this value of var, the number of times equal to the value. So if it is 5, then we will print 5 fives. If it is 6, then we will print 6 6. Okay, so we can do it like this. Okay, so this is the complete code. So our var is starting from 0. Then we will check. If it is less than 10, then it will enter this loop, and we have defined another variable number. So here while true means the condition is just true. You cannot change it to false. So it will by default be an infinite loop, but since we have said that there is a break condition, so this infinite loop will end. So let us do this. First, let us see what will happen if we stop this block. And you'll see that it will keep on running, and we have to manually stop it, and you'll see that it has just printed zeros. So that is again the problem. So the first value was 0, this was true, number was 1, and this while true was infinite loop, and it, although the number increased by 1 at each step, it kept on printing 0, which was the value of r. So now let us do it like this. Okay, this is a small mistake in the code. So it was just a case for the value 0. So we have to check before it was increased. So here our number is starting from 1. So we will start from 0. So now if we run it, you will see that it is working. So it has printed 1 1, 2 2s, 3 3s, 4 4s, 5 5s, 6 6. So we can also, to make it pretty, you can also do it like this. So now you can see that it is printing like a pyramid. So 1 1 2 2 three threes, four fours, five fives, like this. So this is an example where you can also see that this break statement is only affecting this loop, the immediate loop under which the break statement is written, and this is not affecting this loop. This loop is getting affected only by this condition. So this is one example for nested loops and break statement in nested loops. Okay, so we can also check for other values. So when it becomes a two-digit number, the output becomes difficult to be interpreted, but we can easily do till 9. Okay, so this is how we can use break statement. So there is another keyword called continue, which can also affect the control flow. So suppose we have an array A, we have stored these numbers in this array A. So we want to print all the numbers. So for A in A, println. So for I in A, println I and end. So the result is expected. It will print all the numbers stored in this array. Suppose we again write this. Say I equal to, okay. So suppose we write this statement here and let us run it again. So what do you think has happened? Just to compare the outputs, let me have the previous case also and run both of them. So here you can see it is printing all the elements and it is printing everything but 2. So what happens is that when this condition is true, this continuous statement will be executed, and this means that the rest of the code will be skipped. That means anything after this continuous statement will be skipped, but the loop will not end. So this is a nice keyword which you can use to just stop the loop from iterating over certain elements. Okay, so here is a quick problem. Suppose we are writing it like this. So if I execute this code, what do you think? What will happen? So let me run it also. If I run it, nothing will happen because whenever this continue keyword is executed, this means that the rest of the code will be skipped. So for every iteration, so this loop is iterating over all the elements of it. For every iteration, the first statement that it is encountering is continue. So the rest of the code, which again is just one line, println I, will never get executed. So for I equal to 1, which is the first value stored in A, so I equal to 1, encounter this continue keyword, and this will skip and this will move on to the next iteration, and it will go on like this. And if you compare it with this, you will see that for I equal to 1, this condition is false, so this part is not being executed. So this println method is being executed, and we can see that 1 is printed. But when the second element is chosen, where I is equal to 2, this part will get executed, and this continuous statement will make sure that the rest of the code will not be executed. So here 2 will not be printed. Similarly, when it becomes 3, then again it will print. So another simple problem. So what if I change it like this? So this means that whenever the elements are even. So this is checking the remainder, and if the remainder is 0, when we are dividing by 2, then it is an even number, and whenever it is even, then it will execute the continue code, and this part will not get executed. So we see all the even numbers that were in the array, 2, 4, 6 was not there, so only 2 and 4 were there, and they were not printed. So if I make it 1, so this code will now only check when these elements of the array A are odd, and when that is odd, this continue keyword will get executed and the element will not be printed. So you can run it and you see that only the even numbers are getting printed. So these continue and break statements, they are very crucial for controlling the behavior of loop. So I will hope that you have understood how these are used and you will be able to incorporate it in your code also. Okay, so with that, let us now solve some problems. So I have two problems in mind, which will be based on all the classes. So first lecture, second lecture, and the part of this lecture also. So the first problem is print all the Armstrong numbers till 1000, and Armstrong number is a number that is equal to the sum of its own digit, each raised to the power of the number of digits. So an example is also given. Okay, so let me quickly format it. Yeah, and the second problem will be print all the perfect numbers. So a perfect number is defined like this. So in this video, I'll just give you a 5-minute break to think about this problem, and then we'll solve this live in this session. So if you are following along, you can think about it and see if you can solve it. And if you are just want to see the solution, you can skip it for 5 minutes. Okay, so I'm back. I hope you guys have thought about these problems. So let's do the problems one by one. Okay, so let me do the second problem first. So it states a perfect number is a positive integer where the sum of its proper divisors excluding the number itself, those are proper divisors, equal to the number. So a perfect number is a number where the sum of its proper divisors is equal to the number. An example will be 6, where the divisors are 1, 2, and 3, and 6 is excluded because we are not counting the numbers, and the summation of those three divisors is equal to 6. So I think I forgot to write what you have to do. You should have guessed it. Print all the perfect numbers till 10,000. Okay, so let us start. So we will do it within a begin and end block because we'll write all the code in one of the blocks. So now we will start from 1 and let's call it start number and end number will be 10,000. So we have to iterate over all of them and we have to see whether they are perfect numbers. So we can do a for loop and we can define a unit range. We have seen this syntax before, and just to check that this is iterating over all the numbers, we can print I. So I'll just make it 10 for now so that I don't have to scroll through 10,000 numbers. So if you run it, you can see that everything is being iterated over and you can print the number. Okay, so let's make it 100 again. We'll make it 10,000 later. So what we now have to do is get the perfect divisors of the number. Okay, so let us do another for loop because we want to check to all the numbers and see whether the main number, which is I here, is being divisible by the other numbers. Okay, so let us do another dummy variable j and we'll start checking from 1 up to I. But let's see the definition here that we have to exclude the number itself. So we will do I minus 1. Okay, let's end this loop again. So it is again a good practice to comment your code. So this is a loop for checking perfect divisors of the number I. So how do we check if something is divisible by something? We use the percent symbol. So if I, which is our number that we are iterating over from 1 to 100, so, and j is the divisor. So we have to check whether I is divisible by j, and that we can do by checking whether the divisor is 0 or not. So for now, let us just print I and j, and let us again make it just up to say 4 and run it. Um, let's just print a comma also. So you can see that we are starting from 1, but here this is the number, and the second thing are the divisors. So here 2 comma 1 means 2 is divisible by 1, 3 is divisible by 1, 4 is divisible by 1, and 4 is divisible by 2. You can see that we are starting from 1, but 1 is not getting printed because we are not running the loop up to 1. So we can just check here. If we run collect 1 to 1, you will get a array with a single element, which will be 1, and this will give you an empty element. So if you run a for loop where the iterable is an empty element, that for loop will not run. This is same as running a while loop where the condition will never be true. Okay. So here, this is the case that is happening when I is 1, that is the start number. When I is 1, this will become 1 is to 0, and that is giving us an empty array. And since it is giving us an empty array, this part of the code will not run. But when I is 2, then this will give us an array with only one element. And if we do it, we'll see that it will print a single element. Okay. So we can check that this is correct. But the problem is that we have to get the sum of these divisors. So how can we do that? Let us define a variable here again, sum of divisors, and make sure we initialize it with 0. Okay. So when we are checking each number, we'll make sure the sum of divisors is 0. And it is crucial that you put this line after the for loop, because if you put it here, then it will be 0. And if we do something with this variable inside this for loop, then for the next number, this will start from the previous value of this variable. Okay. So we'll see what will happen if we do this. Okay. The program will be incorrect, but why? We will see. So what do you want to do when we are printing this? That means j is a divisor of I, and we want to add the divisor to the sum of divisors. So we are starting it from 0, and if it is 0, then when we are encountering this scenario where our number is 2 and we have found one divisor 1, then this statement will get executed, and that will make the sum of divisors 1. But then again, it will not get executed, and then for 3, it will again be 1, and for nothing, it will get executed. Then for 4, it will be 1. Then again, it will find a divisor 2, and it will be 1 plus 2, 3, but then it will not run again. So it will go on like this. So we have to now check that whether the sum of divisors are equal to the number, whichever number we are checking. So when can we do that? After this for loop. So what this for loop is doing, this is just checking all the numbers and finding whether that number is a divisor of the number that we are checking. So if our number is 10, so this loop will find all the divisors of 10 and add them to this variable. So now the only thing that we have to check is whether this is equal to I. Then we can just print the number I, right? So let us run it, and you can see that it is not printing anything. So that is because the first perfect number is 6. So our end value is 4. So it is not encountering these values. Let's make it 10. And let me also comment out this so that we don't get prompted with these print messages. So if we run it, you can see that it is printing 6, which is one of the example of the perfect numbers. So now let us go to the whole range, which is 10,000, and let us run this code again. And it has stopped executing, and it has printed the number 6, 28, 496, and 81228. So these are the only four perfect numbers that exist till 10,000. So this is a homework for you guys to check whether this results are true. Okay. So now the thing that I promised that I will discuss is what will happen if you declare the sum of divisors equal to 0 before the start of the loop. Okay. And so let us do it for 10, and only it should print up to 6. So let's start. Okay, it is saying that multiple definitions. It's all right. We can just comment it out. This is the answer which worked. So you can comment it out, and you can check whether the results were true or not. Now for just checking, we will run this, and you'll see that nothing is happening. So what we can do, we can uncomment this print statement, and we can also print the sum of divisors. And when it has completed finding all the divisors, we can just print some dashes where the output will be easily readable. Okay, so you can read it now. So let's check. So the first case is 2 comma 1 comma 0. That means the number which we are checking now is 2, and 1 is the divisor of 2, and now the sum of divisors is 0. So just let me slightly change it so that this printing happens after we have added the divisor to the sum of divisors and rerun it. Okay, so now this is the same output. So 2 is divisible by 1, and the sum of divisors is now 2. Now, when we are checking a new number 3, we are again getting that 3 is divisible by 1, but the sum of divisors for 3 should be 1, but it is becoming 2. This is happening because we have defined the sum of divisors to be 0 before the for loop. So whenever the for loop is checking for a new number, it is still retaining the value of the sum of divisors that is obtained for the previous number. Okay, so that's why the error is occurring. So you have to be vigilant about these kind of cases, and to fix it, we have to define it after the start of the for loop. So when that happens, what we'll do, we will run the code again. Yeah. Now you can see that these results are correct. So for 2, 1 is the first divisor and the sum of divisor is 1. There are no other divisors. For 3, 1 is the first divisors and again the sum of divisors is 1. So for each number, this value gets redefined. Okay. So for 4 also you can check. First divisor is 1, sum of divisor is 1. Second divisor is 2, sum of divisor is 1 plus 2, 3. Then nothing is there anymore. So we'll move on to 5. Again, this is a prime number. This will be the only outcome. Now we can check that for 6, 1 is the first divisor. This becomes 1. 2 is the first divisor. This becomes 1 plus 2, 3. Then 3 is the other divisor, and 1 plus 2 plus 3 becomes 6. And this becomes a perfect number, and 6 will be printed. And you can verify the other cases also. Okay. So I will comment this out also and let you guys think about the solution. If you have any doubt about the solution, you can ask me questions via mail or just comment under the video. Okay. So that was the second problem that we wanted to do. Now let us do the first problem, which is print all the Armstrong numbers till 1000. So what is an Armstrong number? An Armstrong number is a number that is equal to the sum of its own digits, each raised to the power of the number of digits. For example, 153 is an Armstrong number because 1 to the power 3 plus 5 to the power 3 equal to plus 3 to the power 3 equal to 153. So suppose you have a 3-digit number, then you will write it like this. Suppose your number is 123, then you check the condition where the 1 to the power 3 plus 2 to the power 3 plus 3 to the power 3 is equal 1, 2, 3, the number itself. And if you have a 2-digit number, say 24, then you will check 2 to the power 2. So the exponent here will be the number of digits. 4 to the power 2 equal 24. So these are the conditions that we have to check to find Armstrong numbers. Okay. So let us solve this problem also. Again, I will just type out the code and explain step by step. But you guys are again requested to check if the solution is correct or not. Okay. So we have to print all the Armstrong number till 1000. Again, let me define the starting number. Okay, I wanted to make it end. So this was 1000. Now we have to check two things here. First, we have to get the digits separately, and then we have to get how many digits there are. Then we can do this check very easily. Okay, so we will do a for loop. and let's see that it is printing everything, and it should print up to 1000. Yeah, so this is good. Now, for each of the case, we want the answer how many digits. Let us say that it is 0 for now, and different digits. We are storing them in an array, and we will initialize them with an empty array. So now, to get the digits, what one can do is take the number and divide it by 10. When you divide it by 10, then the remainder will be one of the digits, and the quotient will be then left with you, which will give you the other digits. Okay, so we can check it. You can say our number is 123, and then we can just print it. We have seen this also. So what this will do, this will give you the remainder, and this will give you the quotient. You can, again, I forgot to run them in begin and end block, and you can see when your number is 123, this will give you the last digit, and this will give you the quotient, which will be the other digits. So if you do it inside a loop, and again after getting 12, you run it again, then you will get the last digit again, and then the remainder will give you another digit. So suppose our number is 4567. If we run it for the first time, then the remainder will give you the last digit, and the quotient will give you the other digits. Then we run it on the quotient again. That will again give you the second last digit, and the other digits will be the quotient. Then you run it on the last quotient again. This remainder will then give you the second last digit, sorry, third last digit, and the rest will be 4, which will be left as the quotient. What we have done here is what we want to do iteratively. Okay, so how can we do that? So first thing that we want to see is, when do we end this? One thing we can think is that we will end it when the quotient becomes less than 10. That means that we have obtained a single digit, which will be the first digit of any number. Okay, so for this we can use a while loop. We can say while I, we will divide it by 10, or actually we want to check the remainder, and where this is less than 10, then we'll keep on doing our iterations. So what do we want to do? We want to get the remainder, that will be I percent 10, and we also want to get the quotient, that will be I, so I can type it properly, I division 10. So what we will do here, how many digits? We will increase it by 1, and different digits. Here we have to add the element, this remainder here. So we can use the vcat function. So if you are unsure whether this will work, you can also check it. Say vcat of an empty array and 1. Let's check what the result will be. You will see that the element 1 will be appended in the array. So this will work as we are expecting. So after 1, if we do 1, 2, this will give you an array which will have 2 elements. So this will work as we are expecting. So the last thing that you want to do is that instead of doing I percent 10, we want to do it on the quotient. So what we can do is make sure that I is equal to the quotient. Okay, so that is completing our code of obtaining the different digits and how many digits are there. So if you want to check if this is correct, we can print it. We can print the number. We can print how many digits, and we can also print different digits. So let me do it for up to 10 only. Let's say we want to do it for 10 to 15 so that we can get some good test cases. So let us run, and I have misspelled different here. So let me just copy it and let me run. This is keeping on running. So let me stop it and see what the output is. Okay, so it is giving you an error. So let us see what the problem was. So you can see that our first value is 10, and when this while loop is starting, 10 divided by 10 will have a remainder 0, and this will be true. But we wanted to run the loop when the quotient was greater than 10. So here this is wrongly defined. So what we can do to bypass this is we can make it a infinite loop, and after this we can run a command, give a condition here when the loop will break. So when do you want to break it? When after having this redefining variable I to the quotient, then we want to check we are dividing it, the remainder is less than 10, and if that happens, then we want to break it. So I think this will be now correct, and let us print it. So you can see this is not printing very nicely, so let me fix that. Okay, if we run it, now you can see that there's another problem that our number is now changed. So we can do one thing. We can store it in a variable and print. Yeah, so this is our number which started from 10. Then this loop is supposed to run forever until this break statement is executed. So it will get the remainder of 10 divided by 10, that will be 0. Then it will have this quotient which will be 1. So how many digits? We will increase it by 1. Then different digits we will add the remainder here, and then we'll make the value I to be equal to quotient. So what is the value? What was the value of quotient? It was 1. So our I is now 1. Now it will check whether the remainder of this division is less than 10. It is 2. And now it will break. So we can check on larger numbers, say 1 to 100 to 110. And you can check that this is still giving us some wrong result. Although it is getting the last digit correctly. This is again happening because after we are dividing it, then this condition is getting true before it is intended to. So just to check, we can run for a 4-digit number and you can see that it is wrong for all the cases. So what is the wrong statement here? That is this. So we do not have to check whether the remainder is less than 10 because the remainder of something divided by 10 will always be less than 10. So this statement was always getting run after one iteration. So if we now stop it, now you can see that it is giving almost correct results. So this is our number. This is getting the last 3 digits correctly for each case. And this is getting the number of digit also correctly, but just it is offset by 1. So what we can do is we can increase it by 1 here and simply at the last, sorry, the first digit that it is missing in every case. So you can see that for all case, it is missing the first one. You can verify from here. So we have to add that to this list. And where is the last digit stored? That is stored in this variable I. So we can write it like this and we can run it. And now we can see that it is getting the number of digits and all the separate digits perfectly. So we can check for a random case, say for this. So this will be 39011, 39011, and it has 4 digits. Okay. So that is correct. So let us go to a smaller example again and run and check. And here you can see that it is a edge case for single digit numbers. It is not working. Let us quickly fix it. So two things we have to fix. We have to first change it to back to 0 and add it later. And let us run it. And you will still see that this part which was correct is correct, but this is again false because this statement should not run for 1-digit numbers. So we have to have a check here, and the check will be checking whether the current number that we are doing is a single digit number. Okay. So single digit number check can be done like this, where correct number %10, that means the remainder is equal to the current number. And then it should not run. So we'll have a not equal to operator here. And then if we run the code block, we'll see that it is printing everything correctly. So for 1, it has 1 digit and the digit is 1. So for 2-digit numbers, 17 say it has 2 digits, 7 and 1. And for 100, it has 3 digits. It has 1, 0, and 0. So everything is working correctly. So for now, we can stop this print statement. And now we have to check this, right? So how can we do that? Do it using a for loop. So what we will do is we'll define a variable check exponent summation and make sure it is starting from 0. Then we iterate over the different digits, and then we make the digit to the power how many digits? So I to the power how many digits, and that will be added to the sorry this check exponent summation, and then you have to check whether current number is equal to check exponent summation. Then we will print the current number. So if we run, we see that we are getting only 1, 2, 3, 4, 5, 6, 7, 8, 9, because up to 100, these are the only Armstrong numbers. And you can verify it because 1 to the power 1, 2 to the power 1, these will all equal to the number. So to check our test case, we can do it up to say 200, and we can see that 153 is getting printed correctly. Okay. So now the problem was to find everything till 1000. So let me increase the final range and run it. And you'll see that we have obtained three more Armstrong numbers. One is 370, 371, and 407. Now again, it is your job to check the answers whether they are correct or not. Okay. By checking the answers, I am asking you not to check the code, but to check whether this is an Armstrong number, this is an Armstrong number by doing this check manually. Okay. And I will give you some homework problems also. So let me quickly just annotate this code. So this is just printing. This is checking with the sum of digits raised to the power number of digits is equal to the number, and this is again a for loop to getting this sum of digits raised to the number of digits. Okay, and this is our main part of code, which is getting us the number of digits and the different digits. Okay, so now I will give you some additional problems to think about. Can we write this code in any different way? Can some inbuilt Julia functions be used to speed up the code? Speed up the code, make the code less small. Can you do it? So basically what I'm asking you two different things. One is to check whether these kind of things or these things can be written in a shorthand way using other inbuilt Julia functions. And then I'm also asking you to check whether this Armstrong number can be found in any other way. Okay. So you can think about these problems as a homework assignment. Let me quickly delete these cells so that everything is tidy. And with that, I think I can stop today's lectures. So as we have been doing in other lectures also, let me quickly note down what we have learned. So first thing is we learned about iterators, which are for and while loops. We learned why do we need to use loops. Then we learned about iterables, upon which we run the loop. We learn about ranges, so unit range, step range, in range. We learned about the colon syntax. We learned about the range function. We learned about the collect function. We learned how to use for and while loops. Then we learned how to break loops using the break and continue keywords. Then we did some problems. Let me quickly check if I have missed anything. Okay, okay. So these are good, these are some. Okay, so this is all that we learned today. And in the next class, we will do the long div thing about root row features. Today's class is also almost over 2 hours, so I will skip this for today's class. We'll start next class with root row features. Then we'll learn about writing functions in Julia. Then we'll learn about positional and keyword arguments. Here also we'll learn about default function parameters. Then we'll learn about user inputs. So suppose you want to make your program interactive and ask the user who is running your code about some input, you can also do that. And then we'll look at multiple dispatch. Okay, and in the next class, maybe if time permits, we'll talk about recursions also. And in the next class, we will start data visualization. Before that, we will install more packages and we'll do data visualization. That means we will be plotting, and again we will do problem solving session. Okay, so with today's class, I think we have completed the very basic part of Julia, learning about the syntax and the control flow. These are considered the basics of a language, and we have completed that. And in the next class, when do we start about learning functions, we'll be doing the intermediate stuffs, and with multiple dispatch, we'll be delving into the more advanced category. And with data visualization, we'll be completing the intermediate part. This will be fourth lecture. This will be fifth lecture. So with that, let me stop today's class here.